Hi, welcome to this quick presentation on the CRFS portable recorder using our RFI radio receiver technology. The mission that we're going to run through here and give you some visualizations for is about the capture and analysis of huge chunks of RF spectrum, which we're able to do in real time and be able to capture that spectrum and replay it in high fidelity. So let's get started. You're probably familiar with the RFI technology at this stage. We build the RF receiver board that can be used by OEM customers inside their own solutions to lever our RF capabilities. But we also put that board into a node, so where we're adding processor, storage, connectivity, building it into a hardened IP67 box to be used out in the field for doing sweeping work, or also, of course, inside our solutions such as our direction finder arrays. And what a lot of our customers really love the product for is, of course, the very wide frequency range, the very deep dynamic range, and very low noise figure, which makes the RFI solution one of the industry best in terms of its capabilities. What a lot of customers are also very curious and interested to use is the fact that our instantaneous bandwidth, our ability to stop and stare at a single chunk of spectrum, is anything up to 100 megahertz in width. And inside of that, because of the incredible speed we have with the heterodyne design of our receiver, we get incredible sweeping speeds of anything up to 400 gigahertz per second. And what that means for our customers is that this device can be used to look at a particular piece of spectrum, zoom in on a particular signal, and then capture that in incredibly high speed. So capture real-time digital transmissions, capturing the I and Q data, and then, of course, being able to take that data away for further analysis, decoding, classification type work. What's interesting is that in using some of our products, which are really designed for the field, sometimes we can't really get the full power of the RFI capability out, and specifically around the high sweeping speeds, because simply we generate so much data that backhaul issues mean it's very difficult to capture that data and be able to store it down to disk fast enough in real time. That's where the RFI portable recorder comes in. Using the same RFI receiver board technology, we package that in a slightly different way, and we've completely redesigned the back end, levering the latest in USB-C and Thunderbolt connectivity capabilities. And what we can do now is stream data live out of our radio, stream it either onto a PC or into storage blocks, and be able to capture at full line rate, be able to capture all of those interesting RF signals that we're looking for on the spectrum. And here we see CRFS own Dave Robertson explaining the solution to a user at the recent Millipole show in Paris. And what you can see is we have our radio receiver daisy chained to a storage block, which is in turn daisy chained to his laptop, and we're showing the spectrum and the waterfall live up there on the screen. And here we can see zoomed in to that screen, we can see the spectrum from 9 kilohertz all the way up to 18 gig, and then the time waterfall sitting underneath. If I run the video, you can see we can do here what we do with all of our solutions. We can zoom in to different parts of the spectrum. As you can see, the resolution bandwidth is improving as we zoom in. This is manually controlled or automatic in this stage. The analysis window, the gray window you see moving around, currently set at 20 megahertz, but we can set up to 100 megahertz of capture window. We position that here just manually over the section of the spectrum we want to capture. We click record, and as you can see, we're recording at incredibly high speed and recording that down into the disk. And here in this case, I've recorded about 8 or 9 seconds worth of data. As we mentioned earlier, the RFI technology is able to perform this incredibly fast scanning speed. What we're going to show you now is, again, back on the show floor here with Dave Robertson, and we're going to show you how the data file manipulation works, how we're able to work with huge amounts of data and process that in a very rapid and efficient way. So let's just take a look at what Dave is doing. What he's doing is, in his recording, he captured around 15 seconds worth of data in his example. He's pointing to the directory where the data files are sitting. Each data file in itself is around 100 megabyte in size. We limit it to that size just to make some sensible manipulation on the hard disk, etc. And what our IQ analysis software will do is, the first time you open the data, it runs through a process like so. If I just press pause, there you go. It runs a summary file of all of that data. So what you can see is, in about 10 seconds there, it's processed, if you look at the blue banner at the top, it's processed 73 individual files. It's 7.3 gig of data in total in that 15 seconds it's recorded. And it's produced these summary charts. And the wonderful thing with this is, the first time you perform that analysis, it takes about 10 seconds just to run through all that processing. But every time you reopen the data and you come back to it, because of the summary file we've created, it's an instant opening. So it makes generating and manipulating all of this sort of data incredibly easy for the operator. Let's zoom in now and take a look at what the screen is telling us. Okay, so I'm going to run a little example. Sorry, I just pulled the laser pointer up so it's easier to point it around the screen. So what you'll see in the IQ analysis tool as I pull some data up is, down in the bottom left-hand corner here, we're going to see a classic waterfall over the frequency range recorded and over the time that we were looking. At the top left, we're going to see the full min-max of the spectrogram in the entire time period. In the top right, what we'll have is, you're going to see some cursors where we're looking at a very specific time slot, which we can adjust, and we'll see the min-max spectra of the time slot we've adjusted. And down on the bottom right-hand side, what we'll see is power over time. Over a long amount of time and over a wide frequency range, this is not so useful. But as you'll see, as we zoom into particular slices of frequency and particular bursts, individual bursts at a microsecond, millisecond level, we'll be able to see the individual IQ signal of that constitutes inside each one of those. So let's run this and take a look now. So what we're doing is, we're loading the files. As I mentioned on the previous, since we've already done a summary file, the loading of these 39 files, nearly 4.5 gigabits of data, is almost instantaneous for you. And as you can see in this particular case, I'm centered around 910 megahertz. And here we're looking at a lot of GSM and LTE uplink and downlink signals. What we're going to do on the next slide is, we're actually going to run that data in real time. And you'll see the different bursts as they were happening in real time. So now it's quite interesting just to press play and let that data roll through in real time. And you can actually see the different signals bursting through in time. To be quite frank, replaying the data in real time, it's kind of interesting, gives you a picture of what was happening. But of course, you're seeing things there really hyper averaged into our time zone. Slowing it down, the ability to zoom in now and look at different artifacts and different signals is really what our customers are aiming to look to be able to do. So let's go in and start doing a bit of that work. So what we're going to do is, we're going to take a look at the data the way an operator would. First of all, what you'll see is, as the operator is pointing his mouse around the different signals and artifacts in the waterfall, what you'll see is our system's got some intelligence to it. It's looking at the frequency, it's looking at the timing of the bursts, it's looking at the shape of the signal, and it's comparing those with the library to do some simple classification work. The operator can easily and quickly see what signal types are there, which ones are recognized, which ones are not, and then they can start to zoom in on specific time slice or even specific signals. So let's run it and take a look. So here we are, the operator's just moving his mouse around, and you can see popping up as his mouse hovers, it's looking at the different signals that are underneath the mouse pointer, and it's giving you its estimate of the classification. The operator can draw a box, zoom into a particular time slice. You notice how the resolution changes as we go and grab that data in higher resolution. And again, you can go and search and now start to zoom in on a particular burst. So you see we're zooming and zooming with higher and higher resolution. You're starting to see the I and Q data. We're walking through the spectrogram in time of that little particular burst. And we can zoom in on the particular IQ. And then actually from here, we can go in and actually export that particular time slot of IQ data. So from the 4.2 gig, we're able to go and grab an individual I and Q burst of a signal which lasted a duration of only 1 millisecond. That I and Q data can then be taken away. It can go and be, as we're looking here, looking at our classification analysis. Let's look at what type of signal modulation we have. Or it could be getting fed into MATLAB or a decoding engine for the operator to be able to recreate the signal which sits behind and start to do some decoding against that signal. So an incredibly powerful tool to literally find the needle in the haystack. So we're getting to the end of this quick presentation. It's been around 10 minutes, hopefully a useful investment for your time. But we really wanted to show the power of the portable recorder. And here now we're able to really visualize and explain to our various users the real power of the RFI technology. And just to summarize, the true power of the RFI technology. A wide frequency range with the ability to be able to zoom down to very, very fine resolution. An amazing dynamic range, an incredibly low noise figure. The instantaneous bandwidth of up to 100 megahertz. And within that, this incredible sweeping speed capability. And remember, this RF receiver board that we build, it's available as a naked board for OEM users to be able to integrate and use. It's available inside our hardened IP67 fit and forget nodes that go to the field. It goes inside the direction finding arrays and the other solutions that we have. And of course, it's also there inside the portable recorder. So some amazing power, some amazing performance deployed in a whole bunch of different ways for our customers to be able to utilize and lever all of this great technology and capability. I hope it's been a useful insight, and I hope the videos will be useful to you as you start to engage your customers. On behalf of the team at CRFS, looking forward to working with you on your future endeavors. Good luck, good selling. Bye-bye.